Okay, so here we go. So here we are, and this is section 4.1, and we're trying to find the sides and the angles of this triangle. So let's just start with, can we find the other angle?
Yeah.
How do we find the other angle?
180 minus
Yeah.
those two angles.
Every triangle holds
180.
180 degrees, doesn't it? Every triangle holds 180 degrees. So if we take the 42 and the 72, and we add them up, what is that? 114? And then subtract from 180, going to get like 66 degrees. So that other angle must be 66 degrees. That good so far? That was easy, right? Triangle has to hold 180 degrees. And they give me side A. A is 8. See it over there? Can I now find side B? We've done this before, right? Go ahead and find side B. Use what we've learned before to find side B.
We can't. It's not a 90-degree angle.
Yeah, does everybody see what's different here? Want to help you. That final exam's coming 2 weeks from Thursday. That's crazy.
So
2 weeks and 2 days from now.
ordinary question is we use sine A over A and then equal.
Right. But why? I want to make sure, because all these formulas and all these things can kind of just mix around in your mind. Let me help you here. Do you see, first off, that we do need something new? That this is similar but different. What's different about this triangle from pretty much all the triangles we've done in this course up to this point?
It's not a 90-degree angle.
It's not a right triangle. You see that? That's a lot of the battle on that final we're going to take in 2 weeks and 2 days, is recognition. When it's all there, 40 problems or so in 2 hours, all from the whole course, how are you going to recognize things? Well, let me help you right now. That's not a right triangle. So forget SOHCAHTOA, right? SOHCAHTOA, all that's right triangle. Why? Because what's in SO, what's the H stand for? Hypotenuse, which is across from the right angle. I don't got a right angle. So forget SOHCAHTOA. Do you see how that's not, we need something new? So first off, do you see that we need something new? All that we did before, SOHCAHTOA, all that opposite hypotenuse adjacent, Pythagorean theorem, all that is only in a right triangle, 90-degree angle. We are busting out of the right triangle world now. We're going to new places. So how do you deal with a triangle when it's not a right triangle? Well, there's a couple of new rules. The law of sines, and in the next section, the law of cosines. There's special laws that help you. And here's what it is. The law of sines is what we're going to use in this section. So really, it's a pretty simple law. It says that the sine of any angle, like the sine of A over A, is equal to the sine of B over B is equal to the sine of C over C. The ratio of sine of an angle and across from its side are consistent and equal in any triangle. That's the law of sines. So, what am I going to do? Well, that means you pair them up. See, I know this A right here, and I know the angle across from it. And I want to find B and the angle, I know the angle across from it. So you match up an angle and the side across, an angle and the side across. See what I'm doing there? So that means the sine of A, 42 degrees, right, this, over 8, so this angle over his side is equal to the sine of B, which is 66, over his side, little b, which I don't know and want to find. Forget about the C. I don't need the C right now. I'll do him in a minute. I just do those two. And you see how I can solve for little b now? Is that making sense? Now I just cross multiply. Just zip, zip. So B sine 42 is 8 sine 66. Diagonal, diagonal. B saying I want to be alone. Bring it up here. So we got b sine 42 is 8 sine 66. How do I get the b alone?
You divide both sides by sine 42.
Divide by sine 42. There it is. Hit the buttons on your calculator, whatever that is. 8. Oh, make sure you're in. Yeah. Well, let's stop there. I don't want to mess you up for the mode because you need to be in radian mode for the test. So leave your calculator in radian mode for the test.